My name is Dr. Charles Bailey-Jones. I'm an Australian Research Council DECRA Fellow and postdoctoral researcher. I'm based at the Monash Biomedicine Discovery Institute, where my research falls under the cancer program. I've always been passionate about science ever since I was a kid. I'm one of those kids that pulled apart their toys at Christmas, and even my dad's ride-on mower at one stage. It's kind of how my mind works. I like to understand how things work. I think one of the defining features of my career that really solidified why I wanted to be a researcher was that moment that all scientists experience, which is that thrill of discovery when you look down a microscope and you are the very first person to see a secret of nature's, to uncover a hidden secret that's been concealed for possibly thousands of years. And when that happened for me the first time, I was hooked. So my project was called Deciphering the Pathways and the Molecular Machinery that Governs Cell Growth. It's around this cholesterol sensor called Lykos. So it's cell growth pathways and how cells respond to essential nutrients. But up until now, we've not really had any insight into how Lykos is able to switch cell growth on in response to cholesterol and how it switches cell growth off. So we used a combination of advanced technologies, supercomputing, and a type of imaging technology called cryo-electron microscopy. And we essentially generated many thousands of images, terabytes worth of data, where we were imaging Lykos, imaging this cholesterol sensor. And then we used this information to reconstruct a three-dimensional snapshot of the structure of Lykos, what it looks like in 3 dimensions. And this is like zooming right into the smallest possible scale of molecules within our cells. We made a couple of discoveries. The first one was that Lykos is this really unique architecture. It's a combination of other machines that the cell uses that scientists are familiar with, but nature's put them together in this new way and it's repurposed it. So that was the first time that any of us had seen this kind of architecture before. It's quite unique. So cholesterol is a really essential component of our cells. All of our cells have this barrier that we call the membrane. It's like the skin of the cell. And one of its core components is cholesterol. So you need cholesterol in your diet. So having a balance where your cells grow in response to cholesterol, but not too much, is really important. Too much cell growth is associated with things like cancer, metabolic disorders, and too little growth would mean that we're not healing properly or we're not developing and growing normally. So today we're one step closer to understanding the molecular processes that govern that. And that means we're now one step closer to being able to intervene and maybe modulate or fine-tune the processes for therapeutic potential.